Today, we are going to be focusing on thermography basics. So we will not be spending much, if any, time in the app itself or on the web console. With that being said, let's go ahead and jump into it. So what is thermography? We're going to start and then talk about sensor size, type, and resolution. We'll do some isotherms information, and then we'll open it up to Q&A as we always do. So first and foremost, as small unmanned systems with IR capabilities start becoming more commonplace in public safety programs, it's important that you guys build up a deep understanding of not only the capabilities, but also the limitations of these aircraft and these sensors. This is very, very important that you guys have a good understanding of how to apply this technology. So what is thermography? Thermography, or infrared thermography, is a process of acquisition and analysis of thermal information from non-contact thermal imaging devices. That means we don't have the ability to walk up and touch it. It's from a standoff point of view. So what does that mean? Well, understand this. Thermal sensors do not actually detect temperature. Whether you're talking about a tick that you're holding in your hand on a structure fire, or whether you're talking about a drone-mounted thermal camera, these things do not actually detect temperature. Thermal sensors are looking for thermal radiation or emitted heat. And then using fancy science, that is thermography, they determine apparent temperature of our target. I hope, again, not gonna dive real deep into the science behind thermography. I just want to give you guys just a very, very basic understanding. But what I want to start with now is sensor size, type, and resolution. And understand, guys, everything that we're going to talk about today is all about platforms that are in the Mavic class range. So Mavics, Anafis, Evos. We're not going to be focusing on any of the matrices or any of the larger aircraft that have the XT, the XT2. Everything we're talking about today is going to be focused more on the smaller platforms. So in the world today, as it relates to drones and public safety, there are two types of thermal sensors: radiometric and non-radiometric. Now, a radiometric sensor has thermal information available at every single pixel across the screen. So it means anywhere you touch on the screen, you're going to get some kind of temperature readout. Now, non-radiometric sensors do not have that ability. Non-radiometric sensors will only give you true thermal information at a 10 by 10 pixel center point. So this is very important for those of you that are flying with non-radiometric aircraft. It's very important to understand that you're going to get better data and better information by trying to cover whatever that target is that you're trying to get a temperature on, by covering that target within that 10 by 10 pixel center point. Now, that's not to say that gathering photo and thermal video from a non-radiometric sensor isn't going to give you the information you want. Your tools and other thermal software can take non-radiometric imagery and still give you an idea about all of the temperature ranges within that image. It's just when you're in real time, true radiometric sensors are going to give you information on the fly at every single pixel. The big thing that we often talk about is resolution on these sensors. And this can have a very, very massive impact on your capabilities and limitations when it comes to your program. So the paired Anafi, so the Anafi Thermal specifically, not the USA, the Enterprise Dual, these are both running true radiometric FLIR Lepton modules. But their resolution is only 160 by 120, or as you can see there, a little under 20,000 pixels. So for everyone on this call that is utilizing those aircraft, you know that beyond 75, 125 feet AGL, you're really, really going to start losing your resolution just utilizing the thermal sensor alone. And so that's why we started to see here in the past few years, with as the technology has rolled out more, the blending functionality as well as the MSX functionality on smaller platforms to help us pull more information out of what we're seeing. Again, because 160 by 120, That's pretty poor resolution, especially if you compare it side by side with some of the larger platforms out there. So when we start thinking about those larger platforms like the Evo 2 series, whether that's, you know, the Enterprise or the 640T, and then we also have the Mavic Advanced and the Anafi USA, all of these aircraft are putting out a module that has a 640 by 512 resolution sensor, or 327,680 pixels, almost 328,000 pixels. So that's more than 17 times the resolution that you get on an Anafi or an Enterprise dual. That's why we're starting to see such a broad uptick in these newer platforms, specifically the Evo, the Mavic Advanced, because they have this higher resolution thermal. Now, one thing to understand is depending on which of these aircraft you choose to go with, some of these platforms have radiometric capabilities and some do not. So specifically with the Mavic Advanced is a non-radiometric thermal. And when we start talking about the Evo 2 series, there are some Evo 2 series aircraft that are radiometric, and then there's some that are not. I believe, and anyone on this call can correct me if I'm wrong, but I believe it's the 640T is actually a radiometric version of the Evo 2. So again, just something to consider if you guys are looking at purchasing additional hardware or trying to better understand. That radiometric can play a big role in your agency and in your fleet. I would like to see, at least having one radiometric capable aircraft, even if it is one that has kind of the lower resolution sensors. But from talking about sensor size, I want to get into kind of the range now of temperatures that these aircraft can measure. So most thermal sensors that are out there right now are measuring temperature range from -20 degrees to 1,022 degrees Fahrenheit. But this cannot be done within a single range or a single gain setting. And one thing to understand here is that not all aircraft that are out there right now have multiple range or gain settings. So for example, the parent Anafi thermal, again, just the standard Anafi thermal, not the Anafi USA, has a temperature range of -10 to 400 degrees. No gain settings on this whatsoever. But when you get into DJI specific aircraft, DJI aircraft can take a range of temperatures from 14 degrees to 284 degrees Fahrenheit on the high gain, and at the low gain, a range of 14 degrees to 752 degrees. Right now, the gain settings can only be adjusted DJI Pilot. I don't know if this is something that has been surfaced through the SDK recently or not. But again, having an idea of what temperature you need to, what temperature you're going to be looking at versus your settings can be incredibly, incredibly important. You may be going to a large-scale commercial structure fire, and if you have your high gain set to that 14 to 284, your sensor's topping out at 284 degrees and not giving you all of the information that is there. And that's simply because these sensors you have to adjust the range and the gain. So just something to keep in mind there for you guys running these aircraft today, especially on the DJI side. You do have multiple gain settings that can be adjusted. The same goes for the Evo 2 series. They have a high gain temperature range of 14 to 84 and a low gain range of 14 to 932 degrees. So again, it's just knowing how to adjust these settings and knowing when you need to apply a high gain versus a low gain, depending on what it is that you're looking at, what you're trying to pull the thermal data from. Does that make sense to everybody? The next thing I want to discuss, because this seems to come up a lot in a lot of the public safety working groups, as well as some of the other forums that are out there, but that's thermal palettes. There seems to be some thought out there that one thermal palette is better than the other, and I'm here to tell you that that is not true. Each and every manufacturer, and even down to different platforms, have a variety of color palettes for you to choose from. There is no right or wrong palette to utilize when doing thermal operations. Some people may like a black hot, some people might like white hot or iron bow or rainbow. They all have their uses. It's just figuring out what works best for you and your agency and figuring out what works best for particular call types. Some might offer better resolution outdoors as opposed to indoors. Some might give you a broader range of colors. It really just depends on what your application is and what aircraft you have. So I want to just pause here and ask a question. From everybody on this call, what palettes are you guys utilizing the most in the field? I know we got some guys that have a ton of experience and some on here that aren't the most experienced when it comes to these kind of operations. What palettes are you having, great success with? Again, no right or wrong answer here. Don't make me start calling names. So white hot and the first one. So I believe that first one in the top left is iron bow. And then Jeff Pitcher says red hot and rainbow, hot metal and black and white. Okay, excellent. So again, guys, it's going to be a range. You're going to find one that works for you. Your partner on tomorrow's shift might be using a completely different set of palettes that work for him. It is just all about figuring out what works best for you and your agency. As you can see from the different answers we got here, none of these guys are using the same palettes at all. But these are all very experienced guys that I would trust. And you can see we have a broad spectrum. So don't ever let anyone tell you that there is a specific palette that you need to be utilizing. There is no right or wrong. It's all about spending some time with the aircraft, figuring out what works best for you. The next thing I want to get into, again, another thing that seems to have a ton of misinformation and a large lack of understanding across, the broad range of public safety, I think, is isotherms, thermal blindness. So first and foremost, what are isotherms, or what is the isotherm functionality? So isotherm functionality is available on a couple of different aircraft, mainly DJI aircraft. But essentially what it does is highlights a range of temperatures with a color change. So this makes objects stand out against a background of a different temperature, or it's used to highlight areas of a field which have exceeded a certain temperature. Again, only offered on radiometric sensors right now, and I believe isotherm functionality is limited just to DJI platforms right now. In a perfect world, isotherms sound like the be-all, end-all. But isotherms, if you don't have a good understanding of how to apply them and some of their shortcomings, you can end up in a situation dealing with what we call thermal blindness. And so what is thermal blindness? So this image right here is giving a perfect example of thermal blindness. Thermal blindness is when we set our isotherms in a temperature range because we think we're going to pick an item or an object or a person out of a background. But one thing to understand about these thermal sensors is they cannot see through glass, they cannot see through concrete, they cannot see through skin. Skin being the key here. They are measuring temperature at the surface of our skin. So what I've seen a lot of times on social media is guys will come on and they'll say, if you just set your isotherms between 80 and 100 degrees and go fly on a cold night, you'll be able to pick humans out no problem because they'll stand out. The problem with that, 80 to 100 degrees is our core temperature. Thermal sensors cannot see through skin. So what if grandma walked out of the back of the nursing home in just her robe? It's a cold night, right? Very chilly night. She's been outside for a couple of hours. The drone team is called out on scene. We put our drone up in the air and we set our isotherms between 80 and 100 degrees because that's what we've been told to do from what we've read on social media. And we go out and we start flying. And we spend 3 hours flying and never find grandma, but one of our traditional ground teams finds grandma and she is pissed off because she's been waving her hands at our drone that's flown over her about 20 times. And now she's wondering why, why we didn't see her. And that's because of thermal blindness. Again, grandma had been out in the cold for several hours. The temperature at the surface of her skin probably closely relates to the ambient temperature of the outside air. So if we've set our isotherms between 80 and 100 degrees and the temp at the surface of grandma's skin is 70 degrees, we're going to fly over her all night and we're never going to see her because we are not appropriately dialing in our thermal sensor. It's not seeing her because we're looking for some objects to stand out that are within that 80 to 100 degree range. And so in public safety, we often talk about these aha moments for how we get, greater buy-in from command staff, how we get bigger budget, more equipment, etc. Well, those aha moments, that's a two-way street. Big wins can lead to program expansion, but big losses, like what we're talking about now, can have your program shut down because we've just spent, let's say $50,000 to spool up our drone program, and we just spent 3 hours flying trying to find grandma, but we completely missed her, and traditional search methods are what found her. So that makes its way back to the chief, and now he's wondering, why are we spending all this money on technology if our traditional methods are what actually went out and found this woman? And it's simply because we did not have the wherewithal and the mindset and the understanding on how to apply this technology appropriately. So it is incredibly, incredibly, incredibly important that you guys train with these thermal sensors. And if you're going to use isotherms, you need to get out there and train with them so that you understand the limitations. Because the same is true on the other side of the coin, where grandma walked out in the cold, but the same thing could be applied on a hot day as well. Let's say we're looking for somebody in a wide open space with a couple of trees. We set our isotherms to a specific range on what we think this person's body temperature would be. Maybe we've set it correctly on what we would think the surface of, or the temperature at the surface of his skin would be out in the direct sunlight. But what if this guy is sitting in the shade of a tree and that's cooled him down significantly? So now that same thermal blindness applies in the same way, whether it's hot or cold. And that's why it is so incredibly important for you guys to get out and do some training to understand the capability and the limitations. And I see Andrew's got his hand raised. So Andrew, if you want to unmute yourself, man, I'll let you chime in here.
Hey, Josh, sorry. I'm dealing with some Winston-Salem stuff.
Oh, no worries. I know what's going on up there.
Yeah, and some other things, so in and out. But the 640T is capable of isotherms. I honestly haven't spent a ton of time with it.
Okay.
My agency, Potter County, is as soon as we have that DroneSense integration with the Autel Smart Controller, that's what we'll be rolling with. So I'll have more to share at that point. Okay,
excellent. That's great. So that I believe that's got to be the only Autel right now that has that functionality. Yeah.
I believe so. Yeah.
Awesome.
Not many people are buying the dual, so we haven't invested a ton of time in it.
Okay. Well, with the big shortage in Mavic Advanced right now, we might see an uptick in agencies putting duals in service. Who knows?
You are exactly right, or the 640Ts for sure.
Yeah.
We've got a limited number for the next probably 4 months, so I think we'll see a lot more 640Ts out there.
Awesome, man. I appreciate you looking into that for me.
Absolutely.
Yeah, guys. So again, it does sound like Autel now has brought in some of the isotherm functionality. So if you're running the Autel 640T, get out there and train on this, guys. This isotherms can be an incredibly, incredibly valuable tool and functionality platforms, but if you don't know how to apply them and if you don't understand the limitations, they can get you in trouble. And again, that is specifically just understanding thermal blindness. The last thing that I'm going to hit on, again, I'm not trying to give you guys licenses in thermography, but I want to throw up some training information that's available out there right now. Specifically with FLIR, their ITC offers a 32-hour public safety UAS specific level 1 thermography course. This is a great course. You will spend a ton of time with thermal sensors, learning to take thermal readings and really understanding the science behind these sensors. This is geared specifically towards public safety UAS operations. So there will be a lot of hands-on time, and it'll be directly related to the types of call-outs and the use cases that we see across law enforcement, emergency management, and fire. Cannot recommend that program enough. That certificate is good for 3 years, and then you have to recertify with some continuing education. There are also some other facilities out there like the Infrared Training Institute and Infraspection Institute. I don't have any experience with those two, but I can say that FLIR's ITC, or the Infrared Training Center, phenomenal. And since since now we're living in this COVID world, they do offer online versions of the course as well, where they will send you out all sorts of course materials. And you basically take the class, take the tests, send the materials back to them, and you'll get your certificate in the mail. Cannot recommend this enough, guys. There used to be, I don't have the link anymore, unfortunately, so maybe you guys can do some digging. But for those of you on the call that are veterans, the ITC used to offer this class and really any of their level 1 thermography courses for free to veterans. I don't know if this is still something that happens since FLIR was kind of merged with Teledyne, but this was something that they did in the past, and I know several agencies took advantage of this. I don't have that link for you anymore, but yeah, do some research. This might be something that is still available to you guys today. And with that, that kind of covers the basic information that I wanted to get out. We'll open it up now and just have some discussion. We've got a lot of very intelligent users on the call, so maybe some of you have had interesting experiences with your thermal sensors. Questions, comments, concerns, I want to hear them all now.
Hey, Josh, it's Coitt. Does anybody else out there doing any mapping, thermal mapping?
I think, Coitt, I think our limitation right now, and correct me if I'm wrong, with thermal mapping is just figuring out which platform that can do the stitching correctly.
Yeah, it does become a problem. You're right, man. I mean, there hasn't been a lot of push for it. I've been working with, Tom Owen very well. And so there's a lot of capabilities within PICS for the thermal mapping. For the organization I came from with Austin Fire, we map, do a thermal map weekly. We found some really good success with that, but you're right. It is based on what hardware they're taking their imaging from.
Yeah.
I'd just be very curious to see if anybody else is using it and what their use cases are for it.
So it looks like Chris Lester's, they've done some messing around with it. Jeffrey Pritchard as well, still experimenting. This is still one of those areas that is so new, because I think we really only have right now PICS with some capability of stitching this information together. And then Raptor maps are the only other ones that I know of, and I know people have had varying degrees of successful interaction with Raptor maps. Just something to consider there. But let's see, trying to get more training done, but hopefully we can get the funds to upgrade to the advanced. The advanced is a great platform. I hinted at this earlier when I was talking with Andrew. There's a pretty massive supply chain disruption right now, and you really can't find the advanced. I don't know of any hardware guys right now that have them in stock. It's a wild goose chase, or trying to find a needle in the haystack really to get your hands on one of these. So that's why when Andrew and I were talking, I mentioned that we might see, an uptick in Autel pushing their 640T again with the supply chain disruption and not having access to the advanced. I think the 640T is probably the next best option. But yeah, when just going back to talking about thermal mapping, though, there is a lot to consider. Your speed, your palette, the time of day that you're capturing this information, whether or not you're able to utilize terrain follow, There's a lot. This is much bigger than crime scene documentation or accident documentation or disaster assessment, because we're opening up a whole host of additional data points that we need to be correct to make this stitching work.
So something we just picked up here recently, Josh, and maybe worth noting, is that within the DroneSense platform, we've got a really great way to map, right? To run your map grids. And maybe that's something for, our team here to start playing with, is even if we can't ingest the JPEGs or JPEGs and actually stitch a map together, it's just using them to fly a grid over some area. Chris Lester, where we were able to work with Chris and some other folks from Austin here a couple weeks ago, and that's kind of what we did. We did through DroneSense. We threw the grid up. We used the thermal cameras. We weren't able to stitch it together, but as we were flying, we could identify, hey, hotspot, pause it, drop a pin on it if we wanted, call somebody over to put that hotspot out. But just actually using the DroneSense map to be able to, or mapping feature to be able to use the thermal tool. I mean, that might be something, a good workaround. Tom was saying that the Mavic 2 Advanced with React could produce a thermal map. So that's something we want to try.
We should definitely experiment with it. I know that some agencies have had better success stitching, because traditionally now aircraft flies one way and then it turns and comes back the other way and then it turns and goes. I've heard of agencies having better success if the aircraft stays on one plane of movement. So going forward and then backward and then forward and then backward gives the thermal data a better opportunity to stitch. So we got a question here. Do all the map stitching programs cost money? For the most part, yes. But if you will reach out to Pix4D, they will give you a free license of Pix4D React, which is their specific platform for public safety. I wish Tom Owen would have been on here to hear this, plug that I'm giving him, but he's not. But yeah, reach out if any of you are connected with Tom Owen with Pix4D. If you reach out to that guy, he will give you a free license of Pix4D React. React is the product that they have put together specifically for public safety. It's essentially fireman proof. You go from like three or four clicks to generating a map. It's that fast and that simple. And our data and the DroneSense data that you'll pull from will integrate seamlessly with React, with Mapper. But yeah, if you'll reach out to Pix, they can get you a free license of React. Coitt, you had mentioned, what you guys were working on a couple weeks ago. Before we jump into that, I want to, Chief Cruz, I see you got your hand up. What do you got?
Hey, Josh, I guess just for the good of the conversation, some learning experiences we've had here in the St. Louis region. Our first systems we purchased, obviously, were custom built for us. Manufacturer went out of business, and we jumped into the DJI world. The first platforms we bought then were the duals. That was the only thing that was available that had that. I guess our disappointment was the quality of the thermal imaging camera in there. And you and I have talked about this before, but I guess it goes back to the saying, you get what you pay for. And so the thermal blindness, the importance of having those settings to maximize the use of that camera is critical to that pilot or that user. But since then, we jumped into the Matrice 300. We just recently took delivery of it. And I guess it's okay to say this through UBT out of Fayetteville, Arkansas. And difference of night and day. The quality of the image that puts out is phenomenal. But there's still a little bit of learning curve as if you don't know how to set those temperature range to find what you're looking for, you're going to come up with bad data as well. But it all depends on the quality of your camera and the settings of those temperature ranges to find what you're looking for. The only disappointment I guess we have, if any, out of the DJI side of the house, we sure did love that MSX feature that was part of the FLIR system. I get this is a Chinese camera, not the FLIR system. It sure would be nice if you had that back in. It's just an enhanced layer, but you got to get them out, you got to fly them, and you got to find out what they'll do and what they won't do.
Yeah, that's the biggest thing, regardless of what the topic is, whether we're talking about flight planning or thermography basics. You just got to get out and fly, because we can sit here and pontificate and we can tell you all the great things that drones can do, but until you go out and you actually figure out how to make your drone do that, it's useless. But yeah, the MSX functionality, the blending functionality that Parrot brought in for that sensor, I think it's great because it does allow you to pull a little bit better resolution, a little bit better image quality out of, again, a 160, 120 resolution sensor. So again, just understanding the limitations, that's going to be a big thing for you guys. But Coitt, I want to get you to hop on back here again. So Coitt and a couple other guys on this call operated on the wildland fire that they had out there in Bastrop, Texas, a couple of weeks ago. I want to turn it over to Coitt to kind of let him talk through, some of what they experienced, some of their use cases and limitations. I think this is valuable to hear from talking about thermal. This is valuable to hear. So Coitt, I'll turn it over to you.
Cool, man. Thanks.
Yeah.
So on the 18th of this last month, or this month, excuse me, I was out doing a demo with Andrew McKinney's group, and as I was doing some training, started smelling some smoke, started seeing the sky turn brown. So I said, "Hang on, guys, real quick." I was on Ops Hub, so I just popped the drone up, took a look, and I'm going to send you guys. Here's a link that I'm sharing with you of the video. That establishing shot is when the fire broke out of its fire line. And so I'm not going to play that right now. Josh, are you playing that?
Yeah, that's me. I've got it up, and I'll let it play.
Okay.
I'll turn the sound down though, so you can keep talking.
Yeah, so you guys will see this establishing shot here.
Another plug for UVT there.
Your UVT, man. Guys are always hooking this up. There's the establishing shot. So that's why I was working with Potter County. And as we were flying, that is when the 30-mile-per-hour winds knocked the fire out of its control line, and then it started moving. That was after I evacuated with my family, and as we were leaving, I was able to put a drone up real quick. And actually, Josh and I were sharing this experience. I sent him the link, and he was watching this from his house, and I got to see what we were going through. So there was Man Aviation came in immediately, and they were hitting it so hard. We had multiple rotary wings. We had several seats come in. Fire attack was up, and then we had a LAT that jumped in and started hitting the area hard. So we were well taken care of during the daytime hours, and we were contending with this high winds and low RH, right? So just a recipe for what you guys know to be a problem for a wildland fire. So then what we decided to do is went to the incident command post and called in went to the incident command post, asked if there was anything that we could do. And they said, "Hey, listen, we have this particular neighborhood that needs to be cleared with the temperature inversions. Smoke had gotten pushed down, and we don't know where the hot spots are at. We're expecting high winds the next day. We need to find the hot spots. Any ember travels, can you guys help?" And so we called the homies. Chris Lester was one of those guys. Came in, he was on his off day. Guy was just hanging out at home. Decided to come in. Got a couple guys on shift there with the Austin Fire Department, and we decided we put together a flight crew. And this video is to describe what we were doing. Right, this is just some B-roll that the news media had, and then we kind of threw our flavor in here. And this is something new, I think, that's going to work out really well. And that is using our drones after hours, because all the aircraft go night. So what we did is we put together some map layers of this neighborhood, and this map layer, this neighborhood happens to be my neighborhood, or our neighborhood. This is where my house is located. So it was just that much more special to us, or to me, to be over it. And Incident Command wanted to see where the hot spots were at, what we were, where the flare-ups were popping up at. And then they would send, the strike team leader would send somebody over with a UTV, and then they would knock it down with the hand crew. And then we would move on and find another hotspot. Once we found the hotspots, and yet you'll notice this map, if you watch this movie again, you'll see that this map was red initially. And whenever we clear an area, a block, then we would turn it blue. And that's why you'll see those different colors. We use Pix4D or PixReact. You saw 345 images. We processed that offline in less than 2 minutes and 30 seconds. 345 images offline, 2 minutes and 30 seconds. They had us looking for the dozer tracks for an after action. So we were able to actually see like how close this fire actually got to us. And we did this all again using our software to do the mapping, and then using both Pix and Drone Deploy to do the processing of the imagery itself. So we collected the fish. The software companies, Pix and Drone Deploy, they cooked it for us, and this is what we ended up getting. We grabbed a bunch of other just kind of B-roll shots to kind of show you how close this fire was on the interface. I couldn't be more proud of our community. The firefighters came in and just did such an amazing job kicking this thing in its teeth from the start. And this is, again, just showing you kind of the map of what we did. And this video is used to help educate, those of us that are in the community that don't quite understand what it is that we're doing and why we need drones to gather this information and share it real time. So, if you got anybody you want to share this with, you've got the link here. Please copy it. Please share it. Huge home run. No homes lost. No loss of life. It was a great win. And again, we used thermal imaging all throughout the night to be able to find those hot spots and be able to direct the ground resources in. And these are just some of the, these are all things that you guys will understand. This is more for the laymen that don't understand what we were doing. But these facts will make a lot of sense to you. Mapping with the thermal camera works really well, and it works great whenever the aircraft go to bed, and we're a no factor for manned aviation. So Josh, thanks for putting that up, man. I appreciate that.
No worries, man. No worries. It's good to have good examples. I'm gonna go ahead and shut that down. Chief Cruz again. What do you got?
Coitt, got a question for you.
Yes, sir.
Going back to your mapping graphic, did you guys grid that out, and then you did the overlay? You put the blue lines on as the areas to be flown?
Yeah. So what we
did the pilots fly that? Did they just fly that perimeter, or how did they come back and then paint all of the squares from blue to red?
Yeah. So great question. So when we roll out with multiple flight crews, we have different positions. I was operating as data specialist. So my position was to draw those grids that you saw, right? And then the mission specialist, the guy that was running our module or module leader that was running us, he said, hey, listen, these are the areas that we have covered. I want you to drive the vehicle over here. Alpha team, you're going to go fly this grid. Bravo team, you're going to go fly this grid. And then they would fly it. They would take their images in and they either give me the cards, or if there wasn't anything there, we just reset and move to the next gridded area. I did a lot of this with screen recording. So that's why when you're looking at it, you can kind of see my browser bar at the top. And I totally recommend you guys doing that. Josh is really good at doing this, like telling stories about how in an incident runs. Is guys, if you have a chance, hit that screen record button, record everything you can just for that background information. And then you can, use it to tell a story and do just this, Chief, is share what, our lessons learned with you.
Thank you.
You bet.
Well, guys, listen, I appreciate you all logging in today. Can't thank you enough. We'll blast out the topic for next Wednesday before we get there. But again, as always, any questions, comments, concerns, you can email us at help@dronesense.com, and we'll do our best to get it answered for you. And we'll see you guys next week.